the next part of the experiment, so we're skipping procedure 3. You're going to jump through procedure 4 through 6. So you're skipping here procedure 3, and you're going to jump to procedure 4 through 6. And so here, right there, procedure 4 through 6, and you're going to enter the values into section 8 and section 9. So section 8 here, section 9. So in procedure 4 through 6, it says here you're going to set the angle to 10 degrees. Don't forget the units. And then you're going to set the mass to 1 kilograms. So that means here then you're going to set the angle to, you're going to keep the angle at 10 degrees for the entire experiment. You're going to set the mass to 1 kilogram. So the mass is already at 1 kilogram. So here you're going to change the length. And the angle is always going to remain at 10 degrees. So you're just going to be changing the value for the mass. Excuse me, you're going to keep the mass at 1, but you're going to change the length for the experiment. You're going to have a small value. I think it's going to range from 0.3 all the way down to 1.5. Actually, no, 0.8. So the length are going to range from 0.3, 0.4, 0.6, and 0.8. So here what you're going to do is you're going to keep the mass at 1. You're going to always release at 10 degrees. And again, measure the time for 5 cycles. So however much time it takes to measure 5 cycles. And then you're going to enter that number here. And you're going to do this 3 times. And the next trial, what you're going to vary here is the length. So you're going to change the length. You're going to go from, do this experiment for 0.3, and then 0.4, and I believe then 0.6, and then 0.8. So here you're varying the length, and you're keeping the angle the same, 10 degrees, and you're keeping the mass the same at 1 kilogram. And you're going to do the same thing. You're going to get your different trials, and you're going to enter your units for length and your units for time, whatever those are. And just like before, you want to calculate the average of these 5 values. So this is 0.75, and then let's say this was 0.7 or 89. So to calculate the average, you can do it by hand, or you can type equals and then average. Yep. Oh, well, I'll just do it H57. And that's the average. And to calculate the experimental period is just going to equal this number, since it's 5 cycles, divided by 5. And the theoretical value, again, you're going to look at your manual. So now this is in a procedure 4 through 6. So you're going to read procedure 4 through 6. So again, you're changing the masses, and you're measuring the time for 5 cycles. And so you're going to calculate the value. You're going to have to use the equation that they tell you to. It's either going to be equation 3.1 or 3.2 to calculate the theoretical period. You're going to put that number there. And then you're going to calculate the percent difference between this number and that number. So let's say that this was 1.9. This is going to be the percent difference between these 2 numbers here. And then you're going to repeat this you're going to repeat what you just did here for the different masses for 0.8, or 0.6, and then 0.4. And now once you completed this section, then now you're going to go to procedure 7 and 8. So it's the same experiment. We're just adding another part to the same experiment here. So actually you're done taking data after you completed this part here. So in procedure 7 through 8, this is just now how to linearize the graph. And the manual says to use this equation to linearize the graph. I actually recommend that you use the one that I refer you to. If you look at here, you're actually going to take the period divided by 2 pi and then square it. And that's going to give you a linearized graph. And so let's see here. So we're going 7 through 8 procedure. And so in section 10, you have those same lengths here that you have from before, right there. And then you have your experimental period here. So then this number, what this is going to be, is going to be the experimental period divided by 2 pi and then squared. So you can do it this way. You can say it's going to equal a quantity squared. And what squared is equal to the experimental period and then divided by 2 pi. And let me try to zoom in here. I don't think I can yet, so let me just do it this way. So this is going to equal then quantity squared. And inside that quantity is going to be, let's see. Yeah, I'll just have to get the cell location. So the cell I want to get is, let's see here, K57. So you can do this manually, but I'm going to show you how to do this in Excel. So then this is going to equal quantity squared, K57, and then divided by 2 pi. So it's 2 times pi. In Excel, pi is capital PI parentheses. And then you're going to calculate each of those corresponding the period for 0.4, the period for 0.8, and the period for 0.6. And you can calculate those numbers there. And then once you've done that, then what you're going to do is you're going to create a plot here of length on the vertical axis and this number on the horizontal axis. And when you do that, you're going to enter that plot here. And here, the reason why I recommend that you use this equation versus the one that the manual gives you is that the slope is automatically going to equal gravity. So once you get your slope here, then that's going to be the value, your experimental value for gravity. So the last part is to do the see how accurate you were in your measurement for gravity. And that's going to be in this section here. So here, the error in the length, that number is already defined up here. That's going to be whatever number you define here to be the error in the length. And I broke up the formula. So this is the same error formula from the last experiment. So there's 2 measured values. There's going to be the length and time. So this is going to be the error in the length divided by the actual length. And this is going to be the error in the time divided by the actual time. Take those 2 numbers, square them, and take the square root of those numbers. And so here I have it broken up into pieces for you. So this one here, this column can represent this set of numbers. And this column here, sigma t over t, is going to represent this set of numbers here. And so to calculate the error for g, it's going to be the experiment, your slope or your value for g, and then multiplied by the square root of this number squared plus that number squared. And that's going to be your error for gravity. And again, don't forget to enter the units for length and these ratios here. And the last part, the value for gravity that you got from the slope here, you're going to enter that over here. So whatever the slope was, you're going to enter it here. And here you're going to choose the biggest value for g, for the biggest value for the error in g. You're going to enter that number there. And then this last part is going to be just a percent difference between your experimental slope and your accepted value for gravity, which was defined up over here. That number there. And there's one formula that I just use for my own purposes. It's just going to be the difference between the accepted and the experimental value for g divided by the error of gravity. And you're going to enter that number here. And after that, you're going to do the homework assignments. There's only 4 questions here. And for the homework here, the one thing you have to be careful here, you're going to enter a number. And only enter a number. Don't enter any units here. So don't enter like 88 seconds. So only enter a numerical value, and also don't enter any symbols. Like plus or minus. That's not going to work either. So only enter a numerical value into this cell here. And then the rest of them are going to be just multiple choice questions. So this completes the overview of how to complete the Gravity Lab on Excel. So don't forget that there's 3 components. There's the actual Excel file, and then there's the manual. That's where you're going to get the instructions from. And then there's this PhET website where you're actually going to do the experiment.